This is Unit 2, Lesson 1, Science, Traits, Skills, and Branches of Science. And so here are some of our guiding questions. What is science? What traits should a scientist possess? What skills should a scientist possess? And what are some of the different branches of science? And so this lesson is just an overall introduction to science. So what is science? A lot of people will say science is everything. Science is all around us. But there is a definition, and this is our definition. It is an organized way of understanding the natural world. So what is the natural world? It means it must be naturally occurring. So it is physical, tangible, has matter, stuff that we can measure, things that we can see and that we can experience with our different senses. It cannot be man-made. So science doesn't study man-made things, it studies naturally occurring things. And so here are some traits of scientists. They should be observant, curious, creative, open-minded, honest, ethical, and skeptical. Scientists can be other things, but these are some of the traits we're going to focus on. So what does it mean to be observant? Scientists must make observations. So observing is the process of collecting information using one or more of your senses. And so those are the 5 senses. You use those to help you make observations about the world around you. There are 2 types of observations. The first is quantitative observation. And these deal with numbers. So if you are measuring something, if you found the ball has a mass of 410 grams, that is a quantitative observation about the ball. If you count the number of children, that is a quantitative observation about the children. So if we do quantitative, it has to have numbers and we need to have units. So units are telling us what the number means. The other type of observation is qualitative. And so that's not using numbers. It's dealing with qualities. So if you're talking about the color, so the ball is red and blue, or there are boys and girls on the playground, that is a description of the ball that is using colors, not numbers. So it is qualitative. Scientists should also be curious and creative. So what does this mean for scientists? For curiosity, scientists should have a sense of wonder. They should ask, why does this happen? Or how does this work? What happens if we do this? What happens if we do that? What happens if the lights are off with the plant? So scientists should ask a lot of questions and be curious about what happens under different circumstances. Scientists should also be creative. They should see the connections between different things, come up with experiments, and try new things. And so these are some ways that being creative can help a scientist. Scientists should also be open-minded. So what comes with that? Being willing to admit you don't know everything. Listen to other people's ideas, especially ones you disagree with. Your opinion on something may change, and that's okay. So if a scientist has a closed mind and they're not willing to look at new things, they'll never understand something completely. And in science, we're always getting new information, so we have to keep an open mind that what we know or what we think we know can change and might change. Scientists should also be honest and ethical. These 2 kind of go together. So honesty is when you tell the truth. And so scientists should report true data. Sometimes it's tempting if you're doing an experiment and you expect results to be one way and your data is not showing that. Sometimes it's tempting to skew your data or change your numbers so that your results look like what you thought would happen. And that's wrong. Scientists should not do that. They should only say what is the true data that they gathered. They shouldn't lie about the results. That's what I just said. And so why might a scientist do this? There's prizes for science, for science fair, for the Nobel Prize. That's a lot bigger than a science fair. But if scientists lie about their results and they make it look like they discovered something that they didn't, that could be something that could get them an award, and that is not true science. Scientists should also be ethical. And so they should have morals. They should respect living things. They shouldn't do experiments maybe that would harm other living things. And so that might be something that scientists have to figure out, like if we're going to test on animals or if we're going to test on people, or what do we consider as right and wrong. That's important for science. Scientists should be skeptical. So what is skeptical? It's not easily convinced, need further evidence or examination. So here we have this guy, and it says gullibility test, and he puts in $1. So if you don't know, gullible means you believe everything. And so this person thinks, oh, I'll put my $1 in. Well, it's gullibility test. He's not going to get his $1 back. He is gullible. That's the result. So scientists should not be gullible. They should be skeptical. They should consider other information. They should need data and evidence. It says they need evidence. They don't just believe things because somebody said it. They want to see the evidence to know that that's the truth. So here are some skills of scientists. Making predictions, classifying, evaluating, making models. Again, there's other skills, but these are the few we're going to focus on. So what does predicting mean? It's forecasting the future events, given evidence of past or current observations. So scientists need to make predictions. What do they think will happen in the future? So here, weather is a big example. So if we have weather patterns, we can predict the weather. It's not always right, but we can make good predictions. Also, we know certain things happen. When you water plants, they grow. So there's certain things that scientists can know will happen. They make predictions, and then they see if those predictions are correct. Classifying. Scientists should be able to sort items into groups based on similar characteristics. So here's the main example I have. You have a bunch of animals. They're all animals, but reptiles share certain characteristics. Insects share different characteristics, and so on. And so being able to put things into groups, and even within mammals, we can sort those into smaller categories or classify it more. Scientists should know how to evaluate, draw conclusions based on evidence. And so if you get results from your data, you have your evidence, you should be able to look at that evidence and figure out, what does that mean? How does that go with my prediction? Does it show my predictions right or wrong? Finally, scientists should make models. So models are representations of complex processes or objects. So a lot of times we think of a model that you make, like a 3D tangible model. But this is also a model. This is a drawing or a figure that shows what the inside of a planet is like. Also, chemical reactions are models, or equations, mathematical equations are models. They show you what happens. And so this is not an actual picture of molecules. It is a model of this chemical reaction. Then the branches of science. There are 3 main categories of science: life science, earth and space, and physical. But then within those, there are more categories. So in life science, we have biology, genetics, cell biology, ecology. And so these are all different types of science that deal with living things. Then we have earth and space science. And so this is astronomy, geology, oceanology. And so these 3 all deal with the earth and space, but not living things. So it's the non-living parts of earth and space. Physical science is about like the physics of how the molecules interact with each other, and that would be chemistry and physics.